Okay, let's continue with our discussion on our um, structural dynamics. Now, this is a topic under structural dynamics. So we already have our equation of motion, no? That is a second order linear, non-homogeneous ordinary differential equation. So this is the equation of that motion. It's equal to P of T or dynamic force P of T. Now, natay klase-klase nga response sa structure, no? First, in the calculation of this structure, we have what we call the free vibration response. And we also have a force vibration response. Sa free vibration response, mauna siya nga ang P of T is equal to 0. The structure is oscillating, there is vibration, but there is no applied dynamic loading. So, may nga rin kung nag-oscillate ang structure or nag-vibrate, pasabot, na siya displacement. Now, ang first vibration mo, ito siyang na dynamic loading. So, natay ko ano, at least three nga kuan dynamic loading. We have the harmonic loading. We also have our periodic loading. And lastly, our impulse loading. So ako ang i-discuss lang karon para mas kuan dali we have our free vibration response. So sa free vibration response, we have also a calculation for the undamped structure and for the damped nga structure. And sa damped nga structure, naputay tulo ka klase. We have the underdamped, and then we have the critically damped, and lastly, we have our overdamped. Yan na. So without further ado, let's start the calculation or for our free vibration response. So sa free vibration response, di ba, as what I mentioned, there is no applied dynamic loading or that is equal to 0. So yung ano niya, itsura. So our equation became a second order linear homogeneous ordinary differential equation. So we have already now a second order linear homogeneous differential equation. Ordinary differential equation. Okay. So first is, let's calculate. Let's try to find a solution, general solution for this one. Now, for this one, we'll try to look for a general solution in such a way that we can have its in such a way nga iyang derivatives can be written in the form constant times its original form. So actually, we can say that the solution of u of t is equal to e to the rt. So let's say no, this is our solution, the general solution of our dE. Now, if we differentiate that, the first derivative is equal to re to the rt, and also the second derivative of the displacement or deformation is equal to r squared e to the rt. So, muna yung pinakadali. So, we can rewrite this one, no, mura siya r times u of t, and this one we have the r squared times u of t. So, mura siya in the form nga constant times its original form. So, why? Nga nga itong i-apply aron mas dali ang ito ang life. Now, if we substitute this general solution sa ito ang existing governing equation of motion, the equation of motion will look like this. We have the mass times, we have the r squared e to the rt plus c. Yeah. You have c times r e to the rt plus k times e to the rt is equal to 0. Now, looking closely at the kuan equation, no na common, so let's divide the whole equation with a common one. Mo to siya si e to the rt. Now, we are left with mr squared plus cr plus k is equal to 0. So from a second order linear homogeneous differential equation, now we have a quadratic equation na. So we call this one our auxiliary or characteristic equation. Now if we divide the whole equation with m or multiply it with 1 over m, natin tayo may mga r squared plus c over mr plus k over m is equal to 0. Now, naku iduga nga variable nato si omega. Unsa man ni si omega? This is our natural frequency. Ang unit ani niya is in radians per seconds or second. So si omega that is equal to square root of k over m. Now kung atong i-substitute ni diri sa kuan atong governing equation, si k over m there is equal to omega squared. So let's rewrite the auxiliary equation natin tay r squared plus c over mr plus omega squared is equal to 0. Okay. So not mo to no, ako lang i-rewrite diri si kuan auxiliary equation. We have the r squared plus c over m r plus omega squared is equal to 0. So now let's start with our first conditions sa free vibration response. Ato si undamped, no? Undamped nga free vibration response. So let's have our solution. So mo yung tag-undamped, so may pasabutan na. Undamped means there is no damping. So pasabot, atong C is equal to 0. So si R squared plus C over M R plus omega squared is equal to 0. 0 na ni siya diri nga term. So we are left with r squared plus omega squared is equal to 0. Now let's find the root. We'll have r squared is equal to negative omega squared. Extract to square root both sides. And we are left with r is equal to positive and negative I omega. So we have I no because the square root of a negative one, that is a complex. Now, so may next step na to. Nanati R. So ito i-substitute si R sa ato ang auxiliary or sa ato ang general solution. So natay do ka R, we have positive I omega. We have also negative I omega. So if we have a general solution which is equal to e to the rt, sa ato pa natay duha ka general solution na atay u1 of t and u2 of t. Now, by principle of superposition, so may tabo. Now, if we add these two solution, that will still be the solution of our differential equation. So we add that, we'll have u of t is equal to g1 times u1 of t plus g2 u2 of t. So, matula na ikuan no, sa susunod na to, we'll have g1 times e to the katong positive, we have the I omega t kay ert man plus g2 times e to the negative I omega t. Now, kani si g1 o si g2, this is our arbitrary constant. So, unsa may next na to buhaton ani para masulbad nato ni siya. No? Actually, mag-apply ta og Maclaurin series or Maclaurin expansion. Lauren series. So, si Maclaurin series, no, this is the special case ni Taylor series. Pero unsa man atong i-expand Maclaurin using the Maclaurin series or expansion? Unsa man atong expand? Natay mga common nga kuan no expansion. We have our e to the ix. So let's say if x is equal to omega t, we can expand this. So this is one of the common expansion, e to the ix. And e to the ix, let's say e to the positive or negative ix, that is equal to cosine x plus and minus I sine x. So we used ano, Maclaurin series for this one, e to the ix. Now, actually, this one is also called the Euler's equation. So, kani si Euler's equation, ato ni ginagamit ni siya sa complex analysis, no? So, from the kuan, nasa exponent si I, nigawas din si I using Maclaurin series, and then, atong na-relate si trigonometric function with the complex analysis. We have cosine x plus minus I sine x, or simply, since ang kuan man solution, general solution is e to the positive negative I omega t. So that is equal this ni cosine omega t plus minus I sine omega t. Ana. So mao man din ni siya ang kuan, what do you call this? Expansion na to ng e to the positive or negative I omega t. So pwede na nato dahil ni siya i-substitute dire. So in the next video, ato ni siyang i-substitute diha.